Okay, we're going to look at the 9.1 to 9.3 chapter review. Find the length of the missing side in the triangle. Anytime we have two sides of a triangle and we want to find the third side, we use Pythagorean theorem. So we're going to use a squared plus b squared equals c squared. And the legs are a and b, so I'll make this a, b, c. We want to find a. So a squared plus 24 squared equals 25 squared. A squared plus 24 squared is 576, and 25 squared is 625. When we subtract 576 from both sides, you get a squared equals 49. So a equals 7. Number 2, it says write the ratios for sine and cosine. So we have the sine ratio. The sine of an angle is opposite over hypotenuse. And the cosine of an angle is adjacent over hypotenuse. So I'm going to fill in the information that I have. Both of them ask us to write it in terms of x. So according to x, angle 5 is going to be the adjacent side, square root of 119 is the opposite side, and the hypotenuse is 12. So I'm just going to fill in my information. I want the sine of x is opposite, which is square root of 119, over the hypotenuse, which is 12. And cosine of x is the adjacent side, so 5 over the hypotenuse, which is 12. So our answer is square root of 19 over 12 for sine and 5 over 12 for cosine, which is C. Okay, the next page. It says write the tangent ratios for y and z, so we just have a different ratio for tangent. Tangent of an angle is opposite over adjacent. And so kind of depends on what side. If we're using y and we have tangent of angle y, our opposite side is going to be 3 and our adjacent side is going to be 5. So tangent of y would be 3 over 5. If we're doing tangent of z, so we're changing our angle, the opposite side is now 5 and the adjacent side is 3. So we have 5 over 3. Tangent of y is 3/5, tangent of z is 5/3, and the answer is D. Number 4, use a trig ratio to find x. So this is where we get to use sine, cosine, or tangent, depending on what sides we have. According to angle 20, the opposite side is 9, and the adjacent side is x. So we have opposite and adjacent. That's for tangent. Tangent of an angle is opposite over adjacent, so that's the one we're going to use. We have tan of 20 degrees, then, is 9 over x. And we're going to use our little trick there where we flip the sides. Put a little 1 under tangent of 20. And I'm going to do the reciprocal. So 1 over tan of 20 degrees is equal to x over 9. And then when I solve for x, I'm going to multiply by 9 on both sides. And that gives me x equals 9 over the tangent of 20 degrees. So you'll take 9 divided by the tangent of 20, and we get x is equal to 24.7, which is C. Number 5, I'm just going to set that one up. That's another one where we have opposite and adjacent. So we want to use the tangent of an angle equals opposite over adjacent. You're going to fill that in and solve for x, and you should get a, which is 6.2. Number 6, that's also a triangle that's going to use tangent. So remember, tangent of the angle is opposite over adjacent. So this is our opposite side, and there's our adjacent side. And for number 6, the answer is D, which is 4. Number 7, this time we have some different sides, not just the legs. So we've got our angle. 11 is the adjacent side, and x is the hypotenuse. So I'm going to use whatever the function that uses adjacent and hypotenuse, which is cosine. Cosine of an angle is adjacent over the hypotenuse. And so cosine of 28 degrees is 11 over x. Again, we're going to, since we've got x in the denominator, we want to flip that ratio. And so I'm going to have 1 over cosine of 28 equals x over 11. And multiply both sides by 11. X is going to equal 11 over the cosine of 28. 11 over the cosine of 28 is 12.5, or A. Number 8, again, we also have adjacent and hypotenuse, so you're going to use the cosine function again. Cosine of an angle is adjacent over hypotenuse. And the answer to number 8 is 8.1. Number 9, we get to see another function. This time we have the opposite side and the hypotenuse. And that's going to be our sine function. Sine is opposite over hypotenuse. So we have sine of 35 is equal to 18 over x. We're going to flip that fraction. We get 1 over sine of 35. Now the only reason why we're flipping these is because we have an x in the denominator and it needs to be in the numerator. That's the only reason why we're doing this. Multiply 18. X equals 18 over the sine of 35 degrees. And x equals 31.4, which is B. Number 10. There's our angle. We have opposite side and hypotenuse. This one, opposite and hypotenuse, again is sine. Sine of the angle is opposite over hypotenuse. So I have the sine of 20 degrees is equal to x over 18. I just want to look at this one because we don't have to flip the fractions this time because we already have x in the numerator. We can just multiply by 18. And so in your calculator you're going to take 18 times sine of 20 degrees, which is 6.2. Number 11, it looks like a little word problem, but really we're just focusing on that triangle, and we want to find x to the nearest tenth this time. We have opposite and hypotenuse. So again, you're going to use your sine function. Sine of the angle is x over 4.1. And number 11 is D, 2.4 meters. Don't have a lot of room there for number 12. I'm gonna bring him down here, where I have a little bit more room. Viola drives, because we have to draw a picture here, Viola drives 170 meters up a hill that makes a angle of 6 degrees with the horizontal, which means that we just have a right triangle, and she's going from the bottom up, and that length is 170 meters. And the angle that she's making is 6 degrees. We want to know to the nearest tenth what's the horizontal distance. So this is the horizontal distance here. And then when we set that function up, we have the adjacent side and the hypotenuse. So adjacent and hypotenuse is cosine. We're going to do the cosine of 6 degrees is equal to x over 170, and then you multiply both sides by 170. And the answer then for number 12 is B, 169.1 meters. Number 13, the students in Mr. Collins' class used a surveyor's measuring device to find the angle from their location to the top of the building. They also measured their distance from the bottom of the building. The diagram shows the angle measure and the distance to the nearest foot. We want to find the height of the building. So it's just telling us what we want to find, really. I'm not so worried about the problem, as I already have the picture. So there's my angle. I have the adjacent side and the opposite side, so I'm going to use tangent for this one. Tangent of an angle is opposite over adjacent. So the tangent of 72 degrees is equal to x over 100. And I would just multiply both sides by 100 and get 100 times the tangent of 72. And that gives me the height of the building to be 308 feet. Number 14 says a large totem pole in the state of Washington is 100 feet. At a particular time of the day, the totem pole casts a shadow. We just want to find the measure of angle A. That's all we're concerned about. We've got the picture already. And we have opposite and adjacent sides. So this time we want to find an angle. We do this a little bit differently. We still set up our function. So tangent of an angle equals opposite over adjacent. We fill in what we know. We have tangent of angle A is 100 over the adjacent side, which is 249. We don't just want the ratio, we want to find the angle A. So to do that, we're going to, it's kind of like multiplying both sides by the inverse of tangent. Anytime you're finding an angle measure and you need to find degrees, that's when you get to use the inverse button. So that means that angle A is the inverse tangent of 100 over 249. And so angle A is 22 degrees. Number 15 is kind of a sneaky problem. We actually need to draw our two different triangles here. We have a smaller one it's a right triangle with height 12 and degrees 42 and a base that is length W. And then we have the bigger triangle, right triangle again, height 12. This time the base is W plus X, and the angle is 27 degrees. So we're going to use them together. We're going to start with this triangle because we only have one variable. And we have opposite sides and adjacent side. So the first thing we're going to do, tangent of 42 degrees is opposite, which is 12 over w. That's one where we're going to flip it, and we get w equals 12 over tangent of 42 degrees, and w is equal to 13.3. Then we're going to take that 13.3 and we're going to put it back into the w in the other triangle and make that side 13.3 plus x. So that's for triangle 2. So we have tangent of 27 this time because we still have opposite and adjacent sides. 12 over 13.3 plus x. We're going to treat this as one value, and basically we're going to flip it, and we get 1 over the tangent of 27 is equal to 13.3 plus x over 12. Okay, again, we're not going to do anything with that yet. Multiply both sides by 12. And you get 13.3 plus x equals 12 over tangent of 27. 13.3 plus x equals 12 divided by the tangent of 27. It's about 10.3. Or I'm sorry, 20. Let's back up. 23.6. And then you're going to subtract 13.3. I get x equals 10.3. Could be just a little bit of a rounding in the answer key. It's A, which is 13.3 and 10.2. Number 16, we're back to some easier problems. We have adjacent and hypotenuse. Again, anytime you're finding an angle measure, you're going to end up using the inverse. So we have adjacent and hypotenuse. That's cosine of the angle is adjacent over the hypotenuse. And when we fill it in, we're going to get cosine of x equals 15 over 21. Since we want to find x, we're going to do the inverse. So x is the inverse cosine of 15 over 21. And number 16 is D, 44. 17, same kind of problem, except we have opposite and hypotenuse. So this time we're going to use sine. Sine of the angle equals opposite over hypotenuse. And because you're going to want to find the angle, you're going to use inverse sine for that one. And number 17 is 35. Again, we're finding an angle. This time we have opposite and adjacent. So you're going to use tangent of an angle. And when you go to find angle x, you're going to use inverse tangent. So 18 is B, which is 60. 19, you have opposite and hypotenuse. So you're going to use the sine, which is opposite over hypotenuse. Again, when you solve for the angle, you have to use inverse sine. And 19 is 23. Number 20, This is a problem about angle of elevation and angle of depression. When you have a horizontal line cut by a transversal, the angle that's created from the horizontal line down is the angle of depression, and from the horizontal line going up is the angle of elevation. It always has to start with a horizontal line. So when we're looking at number 2, here's our horizontal line, and angle 2 is created going up from that horizontal line, so it is an angle of elevation, and it is going from the tower to the airplane, which is C. Number 21, we're back at some normal problems here again. We have an angle. We have an angle, we have opposite side and hypotenuse, and so that's going to be the sine function. Sine of the angle equals opposite over hypotenuse. Number 21 is C, 8.6. 22, you've got adjacent side and a hypotenuse, so that's going to be cosine of the angle is adjacent over hypotenuse. Now for 21 and 22, we're not finding angles, we're finding sides, so you don't do the inverse sine for those. Number 22 is D. And 23, again angle, you have opposite and adjacent, so we're going to use tangent. And number 23, the answer is 9.2. We've got 24 and 25, both are problems where we have angle of elevation and depression. We have a horizontal line cut by a transversal. This is the angle of depression, but it's not inside the triangle, so we're going to look at its corresponding congruent angle, which is also 10 degrees here. So think of two parallel lines cut by a transversal, alternate interior angles are congruent. So even though this angle is 10 degrees, the angle on the inside that's alternate interior to it is also 10 degrees. And we have opposite and hypotenuse. So I'm going to use sine of opposite over hypotenuse. The sine of 10 degrees is then 200 over x. That's going to be a problem ends up where we divide, so that's x is 200 over the sine of 10 degrees, and x equals 1,151.8. And the last one, really same kind of problem as 24. You can see your horizontal lines and alternate interior angles are congruent, so this is going to be 30. And we have opposite and adjacent sides, so we're going to use tangent. And number 25, the answer is B, 10.4 yards. Okay, happy studying, and we'll see you next week. Bye.